And today I'm going to talk about Wireshark 4, which was recently released. I'm assuming that a lot of you are running Wireshark 4, just because we forced it out as an automatic update. But it includes a lot of cool new features, some that might be obvious, some that might not, and I'll be talking about both kinds of features today. First, let's talk about an obvious update that we made, and that was to the default layout. I don't know if you pulled up Wireshark 4 and noticed that maybe your screen looked a little bit different, and that's because we changed from the classic layout, which we've been using since the beginning of the project, to a slightly different layout, which I think makes better use of the screen. But the old layout kind of follows this precedent, and I don't know does anybody recognize this screenshot? I see a couple of people nodding heads, and they're as old as I am. This is a screenshot from the original Network General DOS-based sniffer application. And it ran on an IBM PC, and it ran on an IBM PC back when the PC was new, back in the old days, in the 80s. And as the title of the slide title says, we owed this layout kind of to punch cards, because back then they only had 80 columns and 25 lines of text to work with. And so if you wanted to show the packet list with the full column width, you had to use the full width of the screen. If you wanted to show a hex dump, you had to use the full width of the screen. And so that kind of forced you, if you wanted to have the packet list and detail and bytes all on one screen, you had to kind of use this layout. And IBM PCs only gave you 80 columns of text because they were compatible with IBM terminals, which came out decades before. And IBM terminals had 80 columns because they were compatible with IBM punch cards. And so you had this constraint that they had to follow due to this really old technology. And nowadays, we don't have that constraint anymore. And so if you take that layout and use it on a modern screen, you end up with this. You end up with a lot of wasted real estate. And and as modern screens have gotten bigger over time and gotten more resolution, this problem it gets worse over time. Not only are screens bigger, but they're also wider. For instance, my laptop I think has an aspect ratio of 16 by 9 or 16 by 10. Anyway, it's wider than the old school CRT monitors, which had an aspect ratio of 4 by 3. So with Wireshark 4, all we did was arrange the packet details and the bytes next to each other. This gives you a little bit more room vertically, but it also lays things out more nicely horizontally. So when we did release 4, a lot of people were asking about the new layout, and this is why we did that. And I hope you like the new layout. I've been using it for probably 10 or 15 years now. If you don't like this layout, that's fine. You can change it in the preferences. If you don't like this layout and you have 400 profiles, that's a bit of a different problem, but we can also fix that on the command line. If you do have a bunch of profiles you want to switch back to the old layout, we can do that, and just stop by the developer den and we'll be able to help you with that. A not so obvious change to Wireshark 4 has to do with the improvements that were made to the display filter engine. And most of these changes were made by one of our developers, João Valverde, who is João here today? Okay. But he did a great job of fixing a lot of old bugs and some inconsistencies in the display filter engine, and adding some cool new features, and I'd like to talk about some of those today. First of all, before we get into this, it might be helpful to talk about filtering in Wireshark and where we do it and how we do it. And if you're not familiar with the display filters or capture filters, that's fine. That's why we have a conference to teach you these things. But the thing to notice here is that it's handy to be able to filter in Wireshark in 2 places. Down here at capture time, and up here in the main application during analysis. And when you apply filters in these 2 different places, it's applied using 2 different pieces of code. In fact, at capture time, the filtering is applied by a separate library called libpcap, which is pretty much an industry standard and has been for a long time. And it uses a filtering language called BPF, which is, again, it's another industry standard. But it has its own language, and that's why capture filters and display filters are slightly different. The thing to know about capture filters is that they're applied to just a blob of bytes that come in off the wire. And so they have to be kind of, I won't say simple, because they're actually very powerful, these kinds of filters. But that's all they have to work with, just this blob of bytes that you just received off the wire, and you have to filter on that somehow. But capture filters are really good at answering questions like, what number is at a specific location in the packet? And if we, take an example filter, IP source 172.16.0.122. If you're capturing on Ethernet and you apply this as a capture filter, that gets compiled down to this little teeny bit of code that runs in this, kind of a small virtual machine in the BPF filtering engine. And since we're capturing on Ethernet, the first thing it does is scan through to bytes 13 and 14 in the packet, first starting at 0, and look for the hex number 0800. That means that we're capturing on we have an IPv4 packet. Once we've established that, we scan a little bit further into the packet and we look for our address, and that's how we apply this filter. That's what happens if you capture with this sort of filter. And as I said, it seems very simple and basic, but it's actually pretty powerful, and you can do a lot of cool things with it. Display filters, on the other hand, don't apply to blobs of bytes. They apply to what you see here, a dissected packet. They're applied after Wireshark has taken that packet and broken it down and extracted all the fields from it and all the other information that it can from it. And it's field-based. I mean, you apply fields like ip.source or tcp.port and so on when you're looking for fields in those packets. And display filters are good at answering all sorts of different questions about a packet, not only about what number might be where in a packet, but also if you're matching an address, which in this case an address has a type that we've assigned to it, or if you can match strings or regular expressions or so on. And you can also apply filters to data after it's been, say, decompressed or decrypted. You can also check on things like timestamps. So you can see if this packet arrived within 300 milliseconds of the previous packet and so on. So you have a lot more flexibility here, but it takes a lot more CPU. Capture filters you can usually apply at line rate at high speed. Display filters, you're not going to get anything near line rate just because it chews up a lot of CPU. But if we take that same filter and apply it as a display filter, IP source is 170.16.0.122. As you can see, we're not looking at a blob of bytes. Like I said, the first thing it does is scan through that packet detail until it finds a field named IP source, and then it matches against that address value that we pulled out of that. And as you can see, this kind of operates a lot differently than at capture time. So now that we're all experts on filters, let's take a look at some of the changes that we've made to the filtering engine. Along with the ones listed here, which I'm going to cover here in a minute, there have been a whole bunch of other improvements and changes that have been made, and I encourage you to read the Wireshark 4.0.0 release notes, because it goes into great detail about all the changes that have been made, and you'll probably find something in there that benefits your day-to-day work. Let's talk a bit about field matching, and let's start with this question: how many times does the field IP source show up in a packet? And the answer is it depends. If the real answer is this: as many times as you can figure out how to fit it into a packet. If you have a tool like Scapy, which lets you generate custom packets, you could make this custom packet that just changed IP and just chains together IP and IP and IP, IPv4 packets, and maybe fit a couple of hundred or maybe a few thousand IPv4 headers into this really big packet. And that's kind of on the extreme end. But on the day-to-day end, you often end up with something like this. This is a packet from Johannes Weber's Ultimate PCAP, and it shows, we start off with IPv4, which is carrying GRE, generic routing encapsulation, which is tunneling another IPv4 packet, which is carrying ICMP, which is giving us an error, which has another IPv4 header. So we have 3 here. And to make things even more kind of maybe useful and confusing, Wireshark has these fields called aliases, which match, in this case, both the destination and source address and destination and source port. But that means that each of these fields are going to show up twice for each IP header and TCP PDU. It makes things really convenient, but it's also kind of vague because you have these multiple fields that you're matching. But if we take that kind of vague convenience and apply it to filtering, if you want to match, say, any packet that contains the address 10.10.10.1, this is the filter that people apply, or the kind of filter people apply all the time. But you can do that, and you've been able to do that forever in Wireshark. If you want to exclude addresses, you can put not in front of that expression and exclude that way. In Wireshark 3.4 and earlier, it was kind of confusing because we had this not equal operator that didn't work the way anybody expected, because it translated to the phrase, if any of these addresses do not match, which if you think about that, it meant that both the source and destination, all the fields had to be 10.10.10.1 in order for this to match. This tripped people up all the time, so this is why we used to color it yellow when people applied this filter. But with Wireshark 3.6, Joao, the developer who made improvements to the display filter language, changed this so that it works like this example up here. And so that works the way people expect now. Along with those changes, we now have an all operator, or an all keyword. You can now say all IP source equals 10.10.10.1, which means that all occurrences of of that field need to match that value. You can also do the same thing with the triple equal operator. These are equivalent. I'm not sure how useful this is for the IP source field, but I'm just using that as an example. But you can also do stuff like all UDP port is greater than 5,000, things like that. So this might match some corner cases for for your day-to-day job. I'm not sure. One of the other cool things is that you can now match specific occurrences of a field in a packet. You can say IP source number 2 equals 10.10.10.1, and if we go back to the previous example, from the ultimate PCAP, that matches the second occurrence of IP source, so that it'll match that first bit of tunneled IPv4 traffic. And you can say IP source number 1 to match this one, and IP source number 3 to match that one, and so on. Display filters also added arithmetic, which is one of the neater things I think about, or at least I think were added. You can do stuff, you can add and multiply and subtract and divide like you would expect. You can also use the modulo operator, which gives you the remainder of integer division. For instance, 5 modulo is 3 because 3 goes into 5 once and you have 2 left over. But you can do a lot of kind of neat tricks with that. For instance, you can say RTP and UDP port modulo 2. That will give you any RTP packet with an odd numbered port, which might be interesting because, well, in this case, a number modulo 2, if it's 0, it's even. If it's 1, it's odd. So this would find any odd numbered ports. You can also do something like this. Show me any packet where the TCP payload length is greater than 0, and it's not a multiple of 512. So if you have a protocol, like a custom protocol that's supposed to send payloads in multiples of 512, this would find cases where that's not happening. You can also use the modulo operator, operator is kind of a wild card, because you can apply something like this. TCP port modulo 1000 equals 443. This would match any server. This would match any traffic running on port 443 or 1443 or 5443 or so on. Like I said, you can kind of wild card things. There are also improvements made to the how we handle text matching. And before we kind of get into details on that, it would be useful to talk about how Wireshark does match text. And as the question says, what does Wireshark look for if you apply this filter? This is not in the ASCII symbol table. It's not in ISO 8859-whatever or EBCDIC or whatever. So it's going to take up more than one byte. What sequence of bytes does it look for in the packet? And the answer today, a good guess today is that it's something to do with Unicode because everybody uses Unicode nowadays. But specifically, it does this. This symbol, this emoji, is part of the Unicode specification. It has an official code point number, 1F4A9. It has an official name, pile of poo, and it has an official UTF-8 representation. And this is the representation that Wireshark looks for, the 8-bit value. So if you apply this as a filter, Wireshark will look for F09F92A9 on the wire. Going a little bit further, if you want to look for text, you can look for the actual text between quotes. You can also look for the byte values that make up your text between quotes. If you use \x as a prefix for each byte, you can escape that out that way. Outside of quotes, you can also just put your byte values between colons like you would match any other byte value on the wire or MAC address or whatever. And with Wireshark 4, you can look for the code point value. You can say \u and then that code point value in the, that's listed in the Unicode spec. As we saw in the previous slide, you can use backslashes to escape out some special things in Wireshark. You can also use \t for tab and \n for new line, which is, these are all kind of standardized in various computer languages and elsewhere in the computing industry. But this is problematic because in some cases, like Windows file system paths, they use backslashes everywhere. I mean, that's how they separate directories. And you run into the situation where if you want to look for a file system path, you have to escape out those backslashes with another backslash, which is really inconvenient. And so I think it was either Wireshark 3.6 or Wireshark 4, I can't remember. We took something from Python called raw strings. You put an R in front of a string, and it will not process any of those backslashes. It will just take the string exactly as you type it. So if you have a situation where you look for backslashes all the time, you can make things a little bit convenient now. Finally, I think this is the last bit on display filters. For a long time within Wireshark, we've had something called the slice operator, which is another thing that we've inherited kind of from Python. And the slice operator says, okay, starting at this position, that first number, position, in this case, position 0, take the next 2 bytes and match against this. So this would start at the very beginning of the packet and take those first 2 bytes and match against BBCC. And like I said, we've been able to do this forever in Wireshark, and it's a really useful feature, but the question is, how do you match the last 2 bytes? Because it's a packet. You don't know how long your payload is. It's usually very dynamic. And so you can't really, you're not sure what number to put there. With Wireshark 4, you can now use negative start offsets. And so instead of, like up here, starting at position 0, down here, that negative value says, okay, go to the end of the packet and back up 2, and then look for the 2 bytes at the end of the packet. And so this kind of makes that more complete. And hopefully people will find that useful. The next section is about conversations and endpoints. Roland Canal was supposed to be giving this part of the talk, but I will do my best to convey the work that he did. For Wireshark 4, he did a lot of work changing and updating and improving our conversation and endpoint dialogues. But like it says on the slide, very quickly, if you're not familiar with these, in older products that came before Wireshark, they would have a display called top talkers. And conversations and endpoints, I think, are kind of a refinement on that because they break it out into 2 separate ideas here. You have, like it says on the slide, who's talking to who. Conversations will show you packets that go back and forth at a specific layer, whether it's, for a specific protocol, whether it's Ethernet or IPv4 or TCP or UDP. And endpoints show you the actual talkers, which matches the concept of a top talker. But again, the endpoints show you, the talkers for each protocol, like whether it's Ethernet or IPv4 or V6 or TCP or UDP or so on. This was the old conversation dialogue, and it worked okay, and it was adapted from the old classic GTK interface that we originally had, and it worked. It mostly worked. It did the job, but it had its issues. Roland went ahead and changed it so that it works like this. You have the same information up here. Internally, the code was updated to be much more clean and much more efficient. He also updated the layout of the dialogue so that all the controls are over here on the left. And here's a better description of what's going on. Along with updating the code internally and the layout, he added a couple of features. You can now export the data as JSON. Before that, we had, I think, CSV and YAML and some other export options that were available, but now it's more complete. You can also, the really cool thing is you can take these tabs. Let me back up. As I said before, you have these different protocols that represent the groupings for conversations. You can take these now and pull them off into separate windows. So if you want to look at the IPv4 and V6 conversations next to each other, you can, or TCP and UDP and so on. So you can just tear off as many as you want and view them side by side. You could not do that before. You can also hide columns. Ethernet's not a good example. One good example is IPv4. IPv4 had a ton of columns because not only do we show the addresses and the bytes and the packets going back and forth, but we also show geo-IP information. So if you have a geolocation database file, it'll match that up to the location of the packet or the ASN or whatever that matches that packet. And so that ended up making the dialogue very wide. And so now you can hide columns, and so you don't have to have you don't have to make your windows so wide anymore. You can also filter column values, which is pretty handy. I think that was it for the columns, or for the conversations and endpoints. A couple of quick items before we pull the developers on stage. One of the big things we did with the 4.0 release is that we don't ship packages for Windows 32 anymore. Does anybody here run Windows 32? No hands, good. This makes me happy. The thing that we noticed was what we see here. In the months leading up to Wireshark 4, I kind of did a quick survey, and none of the Wireshark developers developed on 32-bit Windows or made 32-bit packages. In fact, the only machine that we had that was doing anything with 32-bit Windows was the machine that built the packages. That was the only thing left over, operating in that environment. And so we decided to go ahead and phase out support for that. And it's not going to be a hard cutoff. If you still use 32-bit Windows, you're going to be able to get updates on the Wireshark 3.6 branch, and you'll continue to be able to do that until 2024. But it's just something that's being phased out. Along with the news on phasing that out, a good question is when we might start supporting Windows on ARM, because as the world is kind of moving away from 32-bit Intel on Windows, part of the Windows world is moving towards the ARM processor, much like Apple is. Well, I'm pointing to my laptop, but it's still Intel. I don't have an M1 Mac yet. But anyway, Apple is very much moving towards ARM processor in their ecosystem, and Windows is too. We've done some looking into getting Wireshark running on Windows on ARM, and it looks doable. It's just a matter of making sure that all the libraries we use can be built for that platform, and securing a server that we can use to make those packages. And so that might happen by the time 4.2 comes around. We're not sure yet, but we haven't seen any roadblocks yet, other than just sitting down and doing the work of getting that system provisioned. A couple of other miscellaneous changes. If you Work with equipment that doesn't give you PCAPs and instead will take those packets and dump them out as hex. There's some equipment that does that. It's kind of annoying, but you got to work with what you have. There are two features in Wireshark. There's the import from hex dump feature in the main user interface and the command line utility text to PCAP that would take those hex dumps and convert them to packets, or well, to a PCAP. Prior to 4.0, they had different code bases and worked differently. And one of our developers sat down and took that code and combined it. And so now these work the same. They have the same feature set and the same functionality. A cool thing that I like is that in the Wireshark window, active interfaces are now listed first. And on my laptop, I have, I don't know, like a dozen or 15 interfaces. So prior to that, I had to go digging through and find the active one. But now it kind of bubbles up to the top, which is handy. Excuse me. Finally, we are migrating to Qt 6. If you're not familiar with Qt or Qt, that's the user interface library that we use, and that lets us make sure that we can deliver Wireshark on Windows and on macOS and on Linux and do that effectively. And they've switched their major version of the library to 6, and so we need to kind of move along with that. Not only do they've fixed a lot of bugs, and they've are adding improvements for newer versions of macOS and Linux and Windows. For instance, they support dark mode on Windows better, so that lets us support dark mode on Windows better. It's been kind of a bumpy ride on the Windows side. We tried shipping Qt 6 with Wireshark 4.0.0, and it didn't work quite as well as we expected, so we backed off to Qt 5 for the 4.0.1 release, but that is coming, and will hopefully help us make improvements in Wireshark and make it work better on different platforms. Now's the time in the show where we bring the core developers up, so if you have any questions. First, we'll let everybody make some introductions.
Sure. Well, this is kind of a small sample of the core developers, but we'll do our best. My name is Jaap. I've been working on the Wireshark project since early 2000 somewhere. I got started when we were doing voice over IP. We were making stuff and we're trying to find tools. They weren't really available, so we started to search for stuff, and we came across this tool by this guy, and it kind of did what we needed it to do, but not really. So we made some changes and additions and sent it back, and I found some other things, and I sent patches back to him, and eventually said, well, why don't you do it yourself? So that's how I got started in the project, and well, I've been doing that ever since. My main focus is dissector development and bug fixes. So whenever something weird pops up in dissection of a certain protocol and sparks my interest, try to look at the not so readable documentation about some of those protocols and try to figure out what's going on. And then we'll try to fix it so that it actually does what it needs to do. That's it.
Hello, I'm Peter. I'm not a developer from the Netherlands, like Jaap and Sake. I think kind of like forgot, but maybe I started working on Wireshark in 2015, where I was trying to investigate some TLS traces, but the decryption didn't work. So I fixed that and figured out there were more broken things, so fixed more and more things related to TLS or HP or HP2 or whatnot. So yeah, those are also the areas I'm fixing things in. Anything related to encryption, it's usually interests me as well. So if you have any problem with that, then yeah, I can maybe explain to you, or maybe like help adding new fixes or improvement in that area. Sometimes I also get distracted by UI, or there are many things that can distract me. So you can try your best.
Hello, everybody. My name is Dario Lombardo. I am from Italy, and I've been a core developer since 2016. But actually, I'm very old user of Wireshark, actually Ethereal back in time. I've been mainly involved in the development of the external capture interfaces, those interfaces that show at the bottom of the interface list that allow you to capture from different sources. So this is an open interface, so if you wanted to know more about that, I will be happy to tell you whatever I know.
Hello, my name is Uli Halmer. I'm from Germany. I'm working mainly on issues and core network dissectors.
Morning, I'm Saka Blok. I've been using Estoril since 1998, I think. Or no, I started later, 1999 or 2000, something like that. And I missed some features when I was using it, so I started developing and submitted to the mailing list back then. That was the way we submitted patches. And after being annoying all the people to update or to include the patch, because I was developing on Linux and I wanted to use it on Windows, so I needed automated builds. So I was bugging them like, okay, can you please submit this code? And then after, I don't know, 2 or 3 changes, I said, well, why don't you do it yourself? It's a lot easier for us as well. So I've been a core developer since 2007, and I think I stopped developing or kind of did not do any much development since we moved to Qt, because I'm not a C++ programmer, I'm a networking guy. So I tried to get back in the game, but it's pretty steep. There's a whole software development ecosystem now instead of just the code and just submit patches. So I kind of have a little problem with that as a network engineer. So you can ask many questions about using Wireshark and maybe a little bit about development, but yeah, all right, thank you.
Does anybody have any questions? I mean, this is a great time to be asking them since we're all up here on the stage.
I think it's already mentioned that Qt 6 had some, oh, sorry, the question is, for my VoIP pre-conference class, I advised to use 3.6.8 instead of Wireshark 4. And that's, I didn't dig into all the issues, but I saw some issues coming by regarding the RTP player. And so I just wanted to be safe. Let's do 3.6.8 and then not get into the bugs that might be there in 4. Yeah, as Gerald mentioned, Qt 6 has some new ways of doing things, so there are some bugs related to that.
Yeah, there are a couple of issues here. One is that, okay, when I say VoIP, what do you think? Yeah, okay, but what does that mean? It can mean 1 or 50 of a whole bunch of different protocols. I mean, the VoIP covers this huge area of the industry with all these different protocols that operate somewhat, well, are supposed to interoperate very well, but sometimes they don't. And so, like within, well, in this case, you know, we had this major release, and people went in and they made some improvements to the VoIP code, but that also introduced some bugs, I think, as far as matching up VoIP calls, matching up RTB streams to VoIP calls. And this you know, is a process that we go through because you know, it's really hard to test when you make a specific change to one portion of the VoIP code, like the call matching is a good example, and ensure that you're not messing up somebody else's code and their matching. Because in order to test that, you have to have a whole, you know, this huge set of capture files, and you have to be very diligent about capturing that. And I don't know that we have a complete set for all the protocols that we cover that people can test with. That would be, you know, handy to have. Along with that, you know, there's the actual playing part and listening to the audio, and that depends on Qt, which you know, they made some changes to their audio API, and so we had to catch up with that. And so, you know, there are a couple of issues there, but we're getting them sorted out. We got a few fixed in 4.01, and we're you know, getting a few more fixed.
Just a question to the audience: whoever uses the release candidates before we bring out a new version? That's the reason why yeah. A new version actually is introducing quite a few bugs, because we can't test everything. So if you want to make sure, we could use your help in testing release candidates. If you run them on your captures to see whether there's things changing, not working the way it's expected, so you can file those bug reports back before we release a .0 version, that would be really helpful. And otherwise, you know, we just test ourselves, and we might miss things, and then a 4 or a .0 release might contain some issues. Yeah.
All right. And any other questions? I guess we've told you everything, and so you know everything, and you can go home now.
We're mostly down at the developer den. Anyone seen it already? Down the hallway? Large sign outside. That's where we usually hang out during the week. So if you've got anything on your mind, say, hey, what's this? Pop in, and usually we can direct you to either the person who knows it, or we can already explain you what's going on and what we can do.
Oh, yeah.
One other note for the people that weren't here yesterday in brief conference class. On, I think it's tomorrow, we have a packet doctor class. Packet doctors means that a few analysts will go on stage and analyze trace files they haven't seen before. And to get trace files we haven't seen before, we need you. So we'd like to get some PCAPS files from you. Please make sure they're anonymized, or at least they don't have any sensitive information in it. But if it's a problem that you're currently facing, or something you had before, and you want to see how we approach a trace file, please submit those traces. Jasper is the one, or you can send it to me, or anyone that in the team. It will get to us, and we'll make sure it gets to the doctors, and we'll analyze them on stage. All right.
Well, that's it for this keynote. I did want to say thank you to everyone, and I try to make this clear each time I give a talk that I love working on this project. It's been well beyond anything I expected it would happen, career-wise, and I just wanted to say that Wireshark it is a great and wonderful thing. Not only the application, but the community as well. And that's not due to me. That's because of all of you. Because of our developer community and our users and our educators and sponsors and everybody else that helps out with this project. And this has been an amazing ride for me career-wise and personally, relationship-wise, and I love doing this, and I can't thank you all enough for what you've given me. So thank you.